Welcome back. In this short video, I'm going to try to touch the difference between kinetics versus thermodynamic. We said whenever we're talking about kinetics, the thing that we care about it is speed, how fast the chemical reaction is. How can I speed the reaction? Use high concentration. Go with high temperature. And how about also using a compound that can speed the chemical reaction? And that's a catalyst. Catalyst will run the reaction through a different pathway. That means catalyst is going to drop the activation energy. And that's the way it will do it. We will get exactly the same product, but the activation energy will be lower because the reaction is going through different pathways. Okay, through different pathways. For example, in this case, I see one activation energy without actually a catalyst, and that's going to be the activation energy is really high, so the reaction is going to be slower. Well, versus in the presence of catalyst, this is going to be in the presence of catalyst. That's going to be the number, and it's way smaller than without catalyst. So I'm going to say the red one, it will be faster. Yes, the reaction is moving through different pathways, and I can see some intermediate and transition states. When I say intermediate transition state, the max point, we call them transition state, TS1, TS2, TS3, and those are going to be intermediate 1, and this is intermediate 2 until we get the product. So product is not going to be, it's not going to change. And of course, the starting point was reactants. Okay, now again, let's talk about thermodynamic versus kinetics. Thermodynamic is talking about speed of the reaction. Kinetics is talking about the speed of the chemical reaction. Thermodynamic has nothing to do with the speed of the reaction. Thermodynamic cannot tell you whether the reaction is going to be fast or not, but it will tell you whether those products are going to be stable or not. Okay, stable or not. Okay, let's try some example. We have A plus B is turning to C, delta H of the reaction is minus 12. A plus B, it can turn to D, and delta H of the reaction is minus 17. Question is, which one is faster? Okay, I have no idea about speed of the reaction. Why? Because they gave me no info about activation energy. So no info about activation energy. So you can't say anything about the speed. Anything about velocity. Okay, we can't say how fast is the reaction. But let's talk about thermodynamic. This one, it says minus 12, while the second one is minus 17. Okay, where and how I can use those delta H? Okay, negative, when delta H is negative, means losing energy. The one that loses more energy, it will be the most stable product. Okay, the most stable product. In this case, I have two numbers, minus 12, minus 17. Which one is going to be more stable? I'm going to say D is more stable product. How do I know it? Based on delta H. The more negative the number is, the more stable. Okay, so the more negative number, the more stable product. Keep this one to your mind. We are not talking about math here. Please don't say minus 1 is bigger than minus 2. No, minus here, okay, minus here means losing energy. Plus means gaining energy. This is the difference between negative versus positive number when we are talking about thermodynamics. Now, I have two chemical reactions, A plus B turning to C plus D or E plus F. Okay, I have the two like graphs, and I want to compare those two. I'm going to put them side by side and try to compare them. Okay, let's go with this one. We have A plus B turning to C plus D. Delta H of the reaction is minus 25 kilojoule per mole. The second one, A plus B turning to E plus F. Delta H of the reaction is minus 15 kilojoule per mole. Okay, minus 15. Okay, what's the delta H? Let's highlight the delta H first. Delta H was the gap between reactant and product. Okay, so I go That's a reactant, and here we have products. Okay, this is going to be the delta H for the second reaction is minus 15, and that's going to be delta H of the first reaction, which is minus 25 kilojoule. Okay, the one that has bigger negative number for delta H is going to give you more stable product. So I'm going to say thermodynamic. Okay. Thermodynamics is favoring the first product. That's thermodynamic. It doesn't say anything about delta H of the reaction. It's favoring the C and D product. Now, how about which reaction is faster? Now we're talking about velocity. We want to know the speed, okay? Speed or velocity of the chemical reaction. Okay, in that case, look for activation energy. This is activation energy of the second reaction. Well, that one, forgive me. Okay, I said it opposite. This is activation energy of the second reaction. Well, this one is activation energy of the first reaction. Okay, so I'm going to say activation energy for the first reaction is smaller than activation energy of the second reaction. What does it mean? It means kinetic. Kinetic is favoring, again, the first chemical reaction because of the activation energy. Now, let's go and review the second one. Okay. The second case, delta H did not change because we did not change the product. So still, we are talking about same product. So as you see, I said minus 25 versus minus 15. Thermodynamic is saying this one is giving you more stable product. So the thermodynamic is favoring C and D as product. Okay, no doubt about that one. Okay, now let's talk about kinetic. Kinetics, it says look to the delta H. Sorry, look to the activation energy. Okay. This is activation energy of the first reaction, and that's activation energy of the second reaction. So activation energy of the first, activation energy of the second reaction. Activation energy for the second reaction is smaller than activation energy of the first reaction. So what does it mean? It means kinetics is favoring, okay, it's favoring the second reaction. Okay, but it doesn't mean E and F are the most stable product. Maybe, okay, maybe, and it can happen. Okay, E and F after some time, okay, after some hours, minute, hours, day, like I don't know really. So I'm gonna say after, okay, after T, okay, T minutes time, okay, here minutes, hour, okay, they will turn to C and D. Why? Because C and D are more stable. But the first product that you will get here, the first one, it will be E and F. And after some time, then E and F, they will turn to C and D. It might take a long time to get C and D, but the first product you will get it will be E and F. And this is the difference between thermodynamic and kinetics. Thermodynamic is telling you which product is the most stable product. It's talking about delta H, delta G, and the delta G is, again, is a gap between reactant and product. And well, kinetics, it says which reaction is going to be faster. Okay, which product you will get it first, okay? And that's going to be based on activation energy. And thank you very much.